Hello everyone, welcome to Supriya's Easy Neat. This is part 2 video of distinction between the organic compounds or some pair of compounds. So this is the part 2. If you haven't watched the part 1, please go and watch it. So it will be easy for you to watch this part 2. So let's start the video. First, ethyl alcohol and methyl alcohol. How will you by iodoform test? So how will you distinguish by iodoform test? First, ethyl alcohol CH3CH2OH. When iodoform test is I2 plus NaOH, they give CHI3 and CH3OH plus 4I2 plus 6NaOH, that is iodoform, gives no yellow precipitate because for primary alcohol methanol methyl alcohol cannot give iodoform test, and all primary alcohol gives iodoform test except methyl alcohol. Okay, next, ethyl alcohol and acetone by 2,4 dinitrophenylhydrazine. This we have already found in part 1. So if you have watched part 1, you would have known this. So when the ethyl alcohol does not react with 2,4 dinitrophenylhydrazine, while the acetone reacts with 2,4 dinitrophenylhydrazine, and it replaces water from nitrogen and carbon. This three carbons bind to the nitrogen and form this compound. It is a yellow orange crystals. Next is phenol and ethyl alcohol. How will you distinguish? We have already studied phenol by when reacted with FeCl3, it gives violet coloration. If you have watched in the part 1, it will be easy for you. Next, ethyl alcohol. Ethyl alcohol when reacted with FeCl3, no violet coloration. Only phenol gives violet coloration in FeCl3. Ethanol cannot give violet coloration. Next, benzoic acid and phenol by sodium bicarbonate. Benzoic acid, when reacted with sodium bicarbonate, it gives C6H5COONA plus CO2 plus H2O. So CO2 gives effervescence. And when phenol plus sodium bicarbonate gives no effervescence because phenol is less acidic than benzoic acid. So C6H5OH is less acidic than benzoic acid is C6H5CH2COOH. Phenol is C6H5OH, benzoic acid is C6H5COOH. So acid is benzoic is more acid. Phenol is less acidic. Next, distinction between propanone and propanol by 2,4 dinitrophenol. See here, propanol, it is an alcohol, so there will be no crystals. But when propanone is reacted, it is a ketone group. It has a ketone group, so it will be replacing water will be replaced by three carbon atoms to the nitrogen atom, and you will have yellow orange crystals. Next, ethanol and propanol iodoform test. So both. So when we see this both are aldehyde. CHO group is there. So CH3COHO is ethanol. CH3CH2CHO is propanol. Ethanol gives iodoform test and it gives yellow precipitate, whereas propanol does not give iodoform test. It is and does not form any yellow precipitate. Next is propanol and propanone by Tollens and Felling's reagent. We have already seen for alcohol, both will be positive test. For Tollens reagent, silver mirror will be formed, that is Ag, and then for Felling's solution, it will be forming reddish brown precipitate. Reddish brown precipitate also will be formed. But for propanone, both will be negative. Ketone, for propanone, it is a ketone, so both will be negative. And then pentane 2-one and pentane 3-one for iodoform test. How will you distinguish? See here, this is pent 2-one, pent 2-one, and this is pent 3-one. So here you have at least one methyl group left in the corner. So it will be reacting and it will give a yellow precipitate. But here there are no methyl, only to both sides ethyl group are present. So there will be no reaction and no yellow precipitate is formed. And next, propanol and benzaldehyde. Propanol and benzaldehyde by Fehling solution. How will you distinguish propanol? So it is an aldehyde. So it will definitely give reddish brown precipitate. Uh, while benzaldehyde, when reacted with Fehling solution, it will give no reaction and no precipitate. Methanoic acid and ethanoic acid by Tollens and Fehling solution. So methanoic acid is formic acid HCOOH, whereas ethanoic acid is CH3CH2 COOH. CH3COOH is ethanoic acid. When formic acid, that is methanoic acid, reacted with Fehling solution and it gives a reddish precipitate, where while in tolerance reagent it gives a silver mirror, that is Ag precipitate. And for ethanoic acid there is no brown precipitate when reacted with Fehling solution and no silver mirror when reacted with tolerance reagent. Next, ethanol and methanol by iodoform test. Both are aldehydes. Ethanol CH3CHO, when reacted with the iodoform, it will give an yellow precipitate. While HCHO methanol, when reacted with NaOH, it will give no yellow precipitate because HCHO does not contain any CH3 group attached to it, attached to the carbonyl group. Acetophenone and benzophenone by iodoform test. See here, same concept. To the CO compound, to the carbonyl compound, one CH3 should be left in the group. So only at least one CH3 should be left. No bulky group should be present. Only methyl. If methyl is left alone, then it will give iodoform test. See here, yellow precipitate will form. But in benzophenone, both sides are, we have both bulky groups in the present between the sides of the carbonyl group. So it will not give precipitate, any yellow precipitate. Next, by benzoic acid and ethyl benzoate. So benzoic acid C6H5COOH, when reacted with sodium bicarbonate, it will give an effervescence. We have already seen it. But ethyl benzoate, that is C2H5COO Na, when reacted with sodium bicarbonate, it will not give any effervescence. Next, for benzaldehyde and acetophenone, the by tolerance test, benzaldehyde we know it will give silver mirror. Then next is acetophenone, when reacted with tolerance agent, no silver mirror. Next, methylamine and dimethylamine isocyanate test. This is also very important. Isocyanate test, we use CHCl3 and KOH. So when the prime methylamine, that is CH3NH2, when reacted with CHCl3 and KOH, it gives CH3NC isocyanate. It will give isocyanide. So next is dimethylamine CH3 NHCH3. It is a secondary amine. It is a primary amine. When reacted with CHCl3 and KOH, that is the solution, it gives an no offensive smell is formed. The offensive smell is CH3NC. Methyl isocyanide has an offensive smell. Methyl isocyanide, it has an offensive smell. It is also an important question. Whereas when dimethylamine is reacted, which is a secondary amine, it cannot give any offensive smell. So it does not give any positive test for isocyanide test. Next, aniline and ethylamine. Aniline C6H5NH2. When diazotization, that is NaNO2 plus HCl, gives this compound C6H5N2Cl. When treated with phenol, it gives an this orange dye, para hydroxyazobenzene. It gives this compound. So this is diazotization. And for ethylamine, CH3, CH2, NH2, it will give when it reacted with NaNO2 plus HCl, CH3, CH2OH. When treated with phenol, it cannot give an any orange dye, and so it cannot form diazotization. Only Aniline can form diazotization, whereas ethylamine cannot form diazotization. Next is aniline and N-methyl for isocyanate test. Aniline, when reacted with CHCl3 and KOH, it will give phenyl isocyanate C6H5NC. So it can give offensive smell. Whereas N-methylamine, it is a secondary group, it is a primary amine, it is a secondary amine, and it cannot give any offensive smell. Aniline and benzylamine diazotization and reacting with phenol. See here, we know already aniline, we know already. So Na2 plus HCl, when aniline is reacted, it will give C6H5N2Cl, and when and it is treated with phenol, it will give this orange dye, parahydroxybenzene. Next, for benzylamine C6H5CH2NH2. When it is treated with NaNO2 and HCl, it will give C6H5CH2OH. And when it is treated with phenol, no orange dye is formed. Next comes glucose and fructose. Glucose, when treated with bromine in water, that is which is brown in color, it gives gluconic acid which is colorless. So gluconic acid is colorless and released to HBr. And then when fructose with the Br2 and H2O, which is also a brown color, it will give brown color, that is no change in color. So when glucose reacted with the bromine in water, it will give gluconic acid where the color changes from brown color to colorless. Where in fructose, when it reacted with bromine in water, brown color has no change. So there is no change in the color in fructose when fructose reacts with bromine in water. Next is glucose and sucrose. Glucose gives tolerance reagent, whereas sucrose does not give tolerance reagent. Glucose and starch. Glucose, when reacted with swelling solution, it will give red precipitate because it has CHO group, right? Aldehyde group are there. So when starch reacted with swelling solution, there will be no red precipitate. Or glucose, when the iodine solution, it will not give any blue color. But starch and iodine solution, it will react and give blue color. This is very important. So this is the part 2 video of distinction between some pair of compound. And if you just to revise like this, this material is very easy to revise distinction between some pair of compound. So it will be very easy. They will ask at least one question or two questions to distinguish like this. And revise it. If you want PDF, please comment it below. I will upload it. Next video we will revise another organic important topics, name reactions like that. Thank you. Thanks for watching.